Hi there. As Edgar said, I'm Leslie Swalge with HNTV Corporation. I'm a project manager, and specifically the project manager of the Dallas Levee Remediation Project for the City of Dallas. I'm going to start out. I know a lot of you have probably seen or heard the city give presentations on their balanced vision plan and their Trinity River Corridor project, but I just want to give you guys a quick overview. There's a lot more to what's going on in the Trinity River than just what I've got going on with the levee remediation, so I'm just going to give you a real quick overview of that. You can see on the map that's up on the PowerPoint, the Trinity River Corridor project actually covers about 20 river miles. It goes essentially from 635 on the north down to Interstate 20 on the south side, and covers about 10,000 acres of land along the Trinity River. The Trinity River project is broken into 5 components: flood control, recreation, transportation, environmental restoration, and economic development. I'm going to expand on those just a little bit. Flood control is always first and foremost in everyone's mind. It's the reason we have the levees. It's everyone, life safety is everyone's top priority. So as you can see here, these are the actual levee systems that make up the Dallas levee system. You've got the east levee, which in this map is actually on the north side of the river, and the west levee, which is on the south side of the river. Those protect the Stemmons Corridor, downtown Dallas, West Dallas, Oak Cliff, and then down on the Dallas Floodway Extension, you've also got the Central Wastewater Treatment Plant and the Rochester Park levee system, which are essentially ring levees that protect those entities themselves. Some of the projects that are going on that are related to flood control, as I'm here to talk about today, the 100-year remediation. And then I also just want to clarify, there's also what you're going to hear referred to as the Dallas Floodway Project, which is a joint project between the city and the Corps to look at these same levees, but they're looking at them to the full capacity of the system. The levees are about 30 feet tall. The 100 years only about halfway up those levees. And so the Corps and the city are working together on an authorized project called the Dallas Floodway Project for that. Also the Dallas Floodway Extension Project, which is essentially, ultimately the plan is to extend both the east and the west levees south and east to tie into Rochester and Central, so there's one continuous system of protection out there. Then all the little red dots on this map are pump station locations, which is referred to as the interior drainage. And I'm sure a lot of you are aware of the fact that the city is in the middle of ongoing upgrades to those systems. In some cases, they're replacing pump stations, and in other cases, they're just upgrading. On this slide, we do have a picture of the brand new Pavaho pump station, which just opened this fall and is up and running if and when we have flood issues. The other components of the Trinity River project, I'm not going to get into nearly as much because flood control is what's near and dear to my heart. But you do have recreation. These are just some ongoing projects with lakes, trails, the Audubon Center, and things like that along and within the levees and the river. I think a lot of you are familiar with the transportation projects. The Margaret Hunt Hill Bridge, which we all know is now open to traffic. There's also some ongoing construction on Sylvan, and then other projects that are in the planning stages for transportation functions within the river. And then the last 2 pieces of the Trinity River Corridor project are environmental restorations and economic development. The environmental restoration includes the Trinity Forest, wetlands, things like that, that are being restored and improved within the system. And then, as with any improvement project, economic development is what we hope and are seeing coming following improvements that are being made to the system. So now jumping to the levees, which is where my heart is. I'm going to give you just a little bit of background on the levees and how we got here and where we are with the levee systems. Back in 1908, the city of Dallas saw obviously the worst flood they'd seen to that point, which is actually what initiated the building of levees in the city of Dallas in the first place. In 1908, there were no upstream reservoirs. When the rain came, the floodwaters came and just wound through the city, and there was really a lot of destruction. So in the 1930s, the construction of the original levees began. And in addition to constructing levees, they also at that time relocated the river channel to where you all know it as being today. The river used to just wind up and down through downtown Dallas. And those levees were designed to withstand 2.5 times the capacity of the 1908 flood at that time in the 30s. In the 1950s and being completed by 1960 is when the Corps got involved with the levees. There was a project in the 50s where they actually raised and strengthened the levee system to what we see out there today. At that time, the levees also became part of the federal flood protection system. And the capacity at that time was approximately an 800-year storm event based on 1960 design. In 1968, the city of Dallas assumed ownership of the Dallas floodway system, and what that really means is the city of Dallas took over the operations and maintenance of the levees. The levees were then and are still today part of the federal protection system, and the city does have federal assistance when it comes to their levees. In 1990, some of you may remember this was before I was in the city of Dallas, but in 1990, the largest flood that the city has ever seen occurred. This is actually, it surprises some people to know, this was actually only a 50-year storm event as it came through the Trinity River Channel. The water peaked about 2 feet, within 2 feet of the current 100-year water surface elevation, which is about halfway up the levee. So contrary to what some of the things we've heard, these levees have never been tested to the full height. There's never been water to the top of these levees. Just under halfway up is all the water we've ever seen on this system. In 2007, Congress passed the Water Resources Development Act, which authorized federal participation in the Dallas Floodway Project, which is what I was referring to earlier, where this created that partnership with the city and the Corps to improve the levees for flood risk management, but also to include the Balanced Vision Plan and have the Corps participate and approve the lakes, the trails, the parkway, things along those lines. Then in December of 2007, the Corps conducted periodic inspection number 9. Periodic inspections on levee systems all over the country are scheduled to happen every 5 years. They do an annual inspection every year, but the periodic inspection is a little bit more detailed. Shortly before the periodic inspection in 2007, we're all aware of what happened in New Orleans with Hurricane Katrina. And following Hurricane Katrina, the Corps stepped back and took a look at the way they rate their levee systems, how they assess them with their periodic inspections, and really developed standardized criteria and a template that all levees are measured against. And the city of Dallas was lucky enough to be one of the first cities that actually had a periodic inspection done following Hurricane Katrina. And the way they do their inspection is they go out, drive the levees, look at all the flood control structures, and assess them based on this template. And in March 2009, the city received the results of periodic inspection number 9, and they did receive an unacceptable levee rating. It's worth noting at least that the city, but prior to that, had received all very good and excellent ratings, so this was obviously unexpected to the city. So now, what does the unacceptable rating mean? Really, the periodic inspection itself identified a list of deficiencies of things that were noted as being wrong or not up to standards with the levee system. And those deficiencies can be separated into two categories. Operations and maintenance, which I mentioned before is the city responsibility since 1968. And these items included items like erosion of slopes, vegetation, we had trees growing too close to the levee system, structural damage such as a cracked facade on a pump station building, or concrete spalling at one of the head walls of an outfall channel, and then channel instability, which also similar to erosion is where, at the outfall channels we had some eroding from the water coming through the outfall channels. The other type of deficiency that was identified at that time were what we've been calling system design deficiencies, which are both the city and Corps responsibility. And what they've done is they've rolled all those deficiencies up into that Dallas Floodway Project. So those are being reviewed as part of the overall big picture of the levee system that the Corps and the city are currently actively engaged in looking at. And things that fell into that category would be like levee height. Levees settle over time, so the levee was not up to the original design grade. Slope stability, where we're having levee slides, encroachments. And this was a big one for the city of Dallas because all of the bridges that cross the Trinity River are considered encroachments, some of which even the deck of the bridge is lower than your levee height. So they're really encroaching on the levee. And then under seepage, which I'm going to get into a lot more later. The other thing that happened when the city got the unacceptable rating was that the Corps rescinded a letter of support with FEMA for levee certification. And this is standard. This is what happens when you get an unacceptable rating. But in the past, the Corps has provided the letter to FEMA that says, these levees are good. You can go ahead and include them in your firm mapping and for insurance purposes, and we're all good. Well, when the Corps rescinded that letter, it actually falls back on the city to do an investigation and full analysis of the system and provide the documentation to FEMA that says, hey, these levies can still be certified. Because what FEMA did at that same time in 2009, when they received that letter of when the letter was rescinded, was FEMA begins a de-accreditation process of the system. And what they do when they do that is they start looking at remapping their floodplain insurance maps. And in this case, or in a case like this, which was happening all over the country, they're mapping the system as if the levees don't exist at all. And I have a map coming up that'll show you the repercussions of that. Just to get into a little more details, as soon as the city got their letter and knew that their levies were uncertified, they started working on what's called a maintenance deficiency correction period plan. And what that does is that takes all those O&M deficiencies and they essentially put together a plan, a schedule, a list of what they were going to do to resolve them. And they worked with the Corps and got that approved in June 2009. And what that meant was, while the city was trying to get everything resolved with their levees, if we'd had some sort of flood event and some sort of damage to one of the flood control structures, be it the levee or a pump station or whatnot, the Corps would still have come in and helped the city, despite their status of having an unacceptable levee, to repair as necessary. I also just want to point out that since 2009, all of the 198 items have been addressed by the city and approved by the Corps, so the city is sitting in real good shape with that right now. As far as the system design deficiencies, I don't want to spend much time on this. These are all rolling into that Corps feasibility study. And in that study, the Corps is looking at not only what was identified as being wrong in periodic inspection number 9, but they're looking at any flood risk management improvements and then putting on top of that all of the plans the city has for the Trinity Lakes and the parks and the trails and the parkway. And it'll essentially give them an approval of the overall project that'll all fit together, and it'll be a shared funding between the city and the Corps. And so all of that work is ongoing, and we expect a record of decision on that overall project in the summer of 2014. But this is not related to the 100-year. The 100-year is kind of on a parallel track. There were two projects going on at the same time. This is the FEMA worst case scenario map I was talking about earlier. Luckily the city is not in a situation where this is going to happen, but this was a map that was prepared just to look at worst case scenario. If we remove those levees, what's within the 100-year floodplain? And it's a lot of downtown Dallas, the industrial area, the Stemmons Corridor, West Dallas, Oak Cliff. I mean, it's got huge impacts. When FEMA started their de-accreditation, it's actually supposed to be a 2-year process. What has happened since then is the city of Dallas was not the only municipality, the only location in the country that was in this position. A lot of levee systems were being rated unacceptable, and a lot of them weren't nearly as proactive as the city of Dallas and could not have resolved this. So they went to Congress, and FEMA and Congress are working together actually on a new remapping process, because just taking the 11-mile east levee and saying the whole thing doesn't exist because of one flaw just isn't feasible. So FEMA's looking at their whole remapping process, and that is currently going on at the national level. So FEMA is on hold right now as far as redrawing the maps even within the city of Dallas. So what did that mean to the city? Back in 2009, they immediately started investigating and trying to determine what actually needed to be done with their levees. So the first thing we did was we started with a massive soil investigation, which included looking at all the historic, the recent borings, the parkway, the pump stations, all the bridges crossing. They'd all done a massive amount of soil investigation, and then HNTB supplemented it with additional borings where we felt we needed additional information. And in the end, we actually ended up with almost 4,000 borings and cone penetrometer tests. And I'm not a geotech, so I'm not going to get into that, but information about the soil on the system. It was 30 miles of levees that were looked at in that detail. We also started looking at historic information, as-built drawings. As I said, these levees were originally constructed in the 20s and 30s. There's not a whole lot of as-built information on them, but we did have some information from the core improvements in the 60s, as well as on the pump stations and whatnot that were built. We also did a very detailed investigation into the utilities. Some people would be surprised to hear there are more than 100 utilities that actually cross those levees out there, and a lot of them predate the levee construction themselves, so there was not much information known. So in some cases we were, drilling our soil borings blind, not sure if we were in the vicinity of a utility or not. So There was a lot that went into that. There's a picture up there of what a levee slide actually looks like, and I know a lot of you may be aware that the city has had issues with levee slides over the years. What you're seeing there is actually considered a slough slide. They're very shallow. As long as you remediate them in a short period of time, they're not going to cause a real problem to your levee. So we looked into some of the slide history when we were looking at slope stability. I do just want to point out that through all of our investigation and everyone talking to people that we know that have been here for a long time, there is actually no history of any seepage or substantial slope stability issues within the system, even during the 1990 flood. Historically, these levees have performed very, very well. So, as we started gathering information, the first thing was to take a look at what potential problems did we think we saw out there. And we started that very early in the process, so even before we'd done and gotten all of that soil information and done all the investigation, we kind of took a look at what's the worst possible case of problems we could have out there. What are all the situations we have based on what we knew at that time? And then that in turn went into what we called a levee remediation plan. Excuse me. Where we identified potential remediation measures for all of those potential problems. And what that did for us doing it that early was it gave the city and the Corps and HNTB a good start on getting together to start talking through what remediation measures would different groups like to see. You know, what do we think the right path to head down as we get more information is going to be. So since that time, those reports were actually developed about 2 years ago. Since that time, we've been constantly getting the additional information, all those borings. We got a hard ground survey, just real good information about the system, and we've been refining the problem identification and the levee remediation. And through that, the ultimate goal was to prepare a Section 408 proposal for the Corps. And if you're not familiar with that, that's essentially you put together all the technical data in a report form. And there's a list of requirements that I'm not going to get into, but and you put that together for the Corps, because ultimately what you're looking for on a federal system is a Corps determination that you can do construction or make improvements to your system without being injurious to the public interest and not impairing the usefulness of the system. So basically you're not sacrificing the flood control and you're not doing anything to harm the system that's out there today. And we did get approval earlier this spring on our ultimate 408 package for the levee remediation. And what we determined through all that refinement was that we had about 3.5 miles of areas where we saw that there could be potential seepage issues at some point with a 100-year flood. And if you're not familiar with what I mean when I'm talking about seepage, I'm hoping you can see it on that cross-section there, but essentially with seepage, we've got some potential sand layers down underneath the levee, and if you get enough water you know, up there on your flood, you could create a path where the seepage could come through under the levee and blow out on the land side and create a problem. I'm oversimplifying it. All the geotechs in the room are probably cringing, but but that's it in a nutshell. And you can see on the map the 3.5 miles of area that we were concerned about. There's about 3 miles there on the upper east levee, and then there's a real small portion down at the south end of the west levee. Now I'm going to, did I do that right? Yeah. I'm going to step back for just a minute because I think some of you at least have heard recently in the news about the risk assessment that was done for the system and that these levees may not be in as bad of shape as we originally thought and that, you know, that we can move forward. The Corps did do a risk assessment as part of the Dallas floodway feasibility study, and the Corps led it, the city participated. And what that did was in the risk assessment, you're really looking at analyzing failure scenarios based on probability, not a black and white answer on your analysis. So you're looking at it based on probability of the failure occurring and what those consequences are. You know, life safety is first and foremost in everyone's mind, so what are the consequences if we were to let something happen? The results of that led to a couple of different things. First and foremost, it gave everyone a better understanding of the flood types that we experience. A lot of geotech modeling, you model the water as if it's up there forever, but we learned through some of the modeling and what we really looked at in the system, that's not realistic for what's going on here in Dallas. So they looked at we're going to have shorter duration floods. The other thing they really learned was that the levees are more resilient than originally evaluated. And what I mean was the opinion now of the levees is they're a lot stronger than we thought at the end of periodic inspection number 9. What you'll find with this risk assessment and with most levee systems out there is that your highest risk of failure is almost always going to be overtopping. It doesn't matter how high you build your levee, it could always be overtopped by some massive flood. But this Corps has been updating hydraulic models through this process, in part because you need to model in how the, since these levees were originally built, they've built a lot of dams and reservoirs upstream. And so they've been revising the modeling to incorporate some of that. And right now, this is actually from a city council briefing, so I hope I'm not getting in trouble by throwing out these numbers. But right now they say that the levees, as they sit today, will have the capacity to withstand a 1 in 1,000 to 1 in 5,000 year flood frequency. So that's pretty good protection. The key point I want to make out of this, because really what I want to do is show you what you're hearing a little bit in the media with the recent findings of the Corps versus what we're doing for the 100-year. The bottom bullet there is really my key point. When you take a look at a risk assessment, you're looking at the likelihood that a series of events are going to lead to failure. So, for example, for seepage, you're going to have the flood load, you're going to have the connectivity to the sand layer. Your sand layer is going to connect all the way to the land side so your water can flow through. You're going to have a blowout on your land side. You're not going to be able to intervene, and your levee is going to fail. Well, for the 100-year analysis and what we were required to do for FEMA, we had to stop that seepage from happening in the first place, because we have to be able to show on paper that there is no seepage issue out there, regardless of the chances of it actually leading to failure or a levee blowout or the consequences. Anyway, that's my side note. Back to construction. What we ended up with through our coordination with the city and the Corps was that the best remediation for that 3.5 miles of under seepage was a cutoff wall. Now, the cutoff walls that we chose to put in, we used a mix of soil bentonite and cement bentonite walls. I don't want to get too much into the difference between the two. Just the cement bentonite, you introduce cement instead of the native soil when you're mixing it in with bentonite. And we specifically used cement bentonite on this project because we had to cross both of the Hampton outfall channels. And the cement bentonite sets up a lot quicker. It's harder to construct, but it sets up a lot quicker, and that way we were able to quickly reopen the Hampton outfall channels in the event that we had a flood and they had to use the pump stations. We also used jet grout in select locations. And I'm going to explain jet grout a little bit more later, but that was mostly to address utility crossings and construction under the bridges where we didn't have the clearance. The cost of construction came in at approximately $10 million for that 3.5 miles, and construction did begin earlier this year in June and is ongoing. We anticipate it wrapping up here in the next month or so. I wanted to show it. I'm not sure if you all know what a cutoff wall is. I didn't before I got here. So I wanted to just show this typical section, and I don't know if my pointer's going to work because it's going to be hard to describe, but basically you've got, this is the river side of the levee, and this is the land side of the levee, and down here is that sand layer I was talking about cutting off. And so what we're introducing here is this is the cutoff wall, and it's a low permeability material cut down into bedrock, because this right here is really our critical area, so you want to get down below it. But what you're doing is putting in this low permeability so water flowing from the river will get stopped and won't ever get across and have a chance to blow out here on the other side. Once the cutoff wall's in place, they put a clay cap up here at the top, and if you were to go out there, you could see it today because it's still an active construction site, but 6 months from now, you're not even going to know where those cutoff walls are. They're underground. The grass will be restored above them. We'll have markers out there, obviously, so flood control knows where they are, but they're completely underground and have no impact to the floodplain itself. All right, now I have some fun construction pictures that I'm going to try to explain. This is the slurry bentonite pond that the contractor put in. The contractor did most of his staging near the Hampton pump station. This is the Hampton pump station you can kind of see in the background. But what they need to do, what they start with is this big slurry pond, which is essentially water that was being pulled out of the city hydrants mixed with bentonite. And what they do is they mix it and get the right mix design, because they're testing every day, multiple times, for pH, viscosity, and most importantly, unit weight. And then once they've got the slurry as they want it in the pond, they start piping it up and over the levee And then in some cases up to 3 miles. You can kind of see a pipe right here. They had to pipe it up to 3 miles along the toe of the levee to get it to where they were actually digging the cutoff wall. Excavation of the cutoff wall takes some pretty big equipment. This is a long reach track hoe that can actually dig up to 84 feet deep. It can dig a trench 3 feet wide up to 84 feet deep. In our application, we only needed to go up to 60 feet deep, so we had plenty of excess. And then you can see this is a picture of the bucket here, and there's some teeth on that bucket there, and that's because, like I pointed out on that typical section, you actually have to get your cutoff wall down into bedrock so that you're sure you cut off that sand layer. So they use those teeth to dig out the shale and chalk materials that are under the sand to make sure that they hit that depth on that. This is the actual trench construction, and as you can see on the right, it's just a narrow trench and up to 60 feet deep. Now the slurry, part of the reason that was so critical that they're testing that slurry multiple times daily for its unit weight and density is because that slurry is holding that trench open all the way down to depth. So what they're doing is they're digging that out, they're keying into the material, they're dumping the material that comes out of the trench over on one side, and I'll show you that in a second, and then backfilling with the slurry. So then you've got an open trench with slurry in it. Then they, with that material that they pushed over to the side, what they're essentially doing, and this is a bulldozer in this case that's doing it, but they're working the soil that came out of the trench in with the slurry mix, the watery slurry mix, and they're just working it, farming it there next to the trench until they reach the density, not pH, but the permeability, the slump, the consistency that they need. So they'll work that off to the side of the trench, and then they literally just push it back in. And the key is the density of that slurry obviously of the backfill actually has to be more than the slurry, so it'll displace it. And so they're just pushing that material back in and replacing it, and that's how the slurry wall is essentially created. Now, obviously, this is not an exact science. But that's why, really, we put into our specifications some pretty hard requirements on the contractor, because it's really, it's an art, and they need to know what they're doing. So our contractor was required to have a certain number of years of experience of doing exactly this kind of work. Because as you can see, you're out there working with that material. It's hard to, it's not that controlled environment that I know we all like to see. So, in addition to the slurry wall construction, like I mentioned, we did some jet grouting around utilities and whatnot. And what the jet grouting is it's essentially a drill rig, and they've just converted it so that it can also pump grout. Because what they'll do is they drill the hole down to the key depth, and then they just, as they're backfilling, or as they're coming up, they're just pumping it full of grout, which is displacing the native materials and will create these columns that you can see kind of in this middle picture and this picture on the bottom, these columns that overlap and essentially create a wall. And the reason, especially around utilities, that you do this, like I said, we have so many utilities out there crossing, and you can't, with that long reach track hoe, you don't want to be digging around your utilities, and the utility company doesn't want you digging around their utilities. So you use this jet grout and essentially angle your drilling down around it, so you can miss the utilities, because the critical piece you're trying to cut off is down in that sand layer. You're not really concerned about the fact that you didn't get jet grout right up next to your utility, because you don't need it, because the clay is not permeable. So what you're seeing in these pictures is we did a couple of test sections just to make sure that the jet grout was overlapping and creating what we wanted it to. And so you're seeing the excavation of those test sections there. And then just the next steps of what we've got going on. As soon as construction wraps up, hopefully here in a month or two, we'll be pulling together the construction as-built, which is essentially the last piece of the package of what we need to prepare the FEMA certification package. So once we have all those technical pieces that FEMA requires pulled together, we're going to go ahead, and we believe we're on track to schedule or to submit the final FEMA package to FEMA in the spring of 2013. And as I mentioned earlier, with them on hold, we're well in advance of any remapping of the levee systems. And then I just wanted to mention ongoing, you're also going to continue to hear about the Dallas levees with the feasibility study while the city and the Corps continue to collaborate on what the ultimate picture of what they're going to build out there is going to be with flood risk management and the balanced vision plan. And we expect the record of decision on that in the summer of 2014. With that, that is what I've got. So if there's any questions or if I can answer anything. Yeah. The cost of the cutoff wall was $10 million for construction. I believe that the money came from, I actually know the answer to this, but I can't think of it. I think it came from, they pulled some money from some of the other pump stations and some of the other flood control projects that they had planned for the future that were, I believe, in the 2006 bond program. So, but, go ahead.
Will HNT be certifying the levy?
Sort of. HNTB will be sealing the technical package that we will give to the city. We'll seal the package saying it meets what was in FEMA. You know, we're sealing our analysis, our work, and then the city. I believe it's going to be the assistant city manager, but the city manager or the assistant city manager will actually seal the overall package that is submitted to FEMA. So, yes and no. Yes, sir.
About how many utility or conduit crossings were there in 3.5 miles? And about what was the oldest or most critical one of those?
The jet fuel line that runs to Love Field was the most critical. There were 5 jet grout windows. I know in one of those windows we had 18 fiber optic utility lines, a gas line, and a water line all in the same place. So there were probably 10 to 12 actual utility crossings. So, yes, sir.
I just heard recently about a proposed golf course in South Dallas. Is that going to be impacted by any of your work?
No. Yes, sir.
When you look at your record of decision in 2014, will the FEMA maps be reissued at that time?
The FEMA maps aren't going to be reissued. I shouldn't speak for FEMA, but the ongoing project with the Corps should not affect the FEMA maps because what we're doing now will show that those levies are okay for the 100-year. That record of decision will affect the full capacity of the levies, the 1,000-year flood or whatever it becomes. And FEMA doesn't really care above the 100-year. FEMA always is. They have their set schedule of when they review maps. I know right now they're looking at some of the interior drainage and how that affects the existing mapping. But no, the record of decision won't affect it. Anyone else? Okay. Well, I'll stick around for a little bit afterwards if anybody has any other questions. Thank you guys very much.